Okay, we say that resistors are in series as long as the same current flows through them. Resistors are in series as long as what? If the same current does not flow through them, no matter their configuration, no matter the way they look, they are not what? They are not in series. If you don't get this thing, you will have issues with this course. On the other hand, we say that resistors are in parallel when the voltage across their terminals are equal. When the voltage across their terminals are what? When they have the same potential difference applied across their terminals. That is the only time we can say that what? They are what? In parallel. That's why you look at this, you may think they are in parallel. What if I decide to put a current source here? Are they still in parallel? So you notice that you can't use this kind of arrangement to say they are in parallel or what. So if you want to find out whether these components are in series or in parallel, just ask yourself, is it the same current that is flowing through them? If it is the same current, no matter how they look, they are in what? They are in what? If it's the same voltage that you can get across them, no matter how they look, they are in what? They are in parallel. That's number one. So let's look at this. Based on your secondary school physics, which resistors are in parallel here now? Which one are in series? R3 and R4 are in series. Okay? R2 is in parallel with. Is she correct? Yes. Meaning that if we want to find the effective resistance in this circuit, that is, effective resistance means the total resistance that this source sees looking from here. That is, looking from here. I mean, if I want to find effective resistance, just as I stand now, I'm looking inside from this point, because that's what the resistance this source, that is opposition to its flow of current. Good. It means it's going to be what? R1, because R1 is in series with all of them. True or false? So, plus R2 parallel what? Does that make sense to you now? You need to understand this at this level. If you don't understand this at this level, when we begin to talk about Thevenin's theorem, Norton's theorem, you'll be confused. Yes, it's a very simple stuff. Yeah? We're not following the number. We are following. You know what we are following? We are following the way current flows. The current came here. Let's assume I came here. It divides into I1 what? I2. So by the time you add I1 and I2, you are going to get what? I. Telling us that it is the same current that flows through R1 that is flowing. It came here splitted, but it's the same current. So what it means that if we want to get the effective resistance of this circuit, it becomes R1 plus R2 parallel what? R3 and R4. Then you solve from here. You solve what? You solve from here. And when we solve from here, I'm sure you still remember your fundamental physics. If we have R1 and R2, I don't want to get into the derivation. I believe that you did your fundamental physics before you came to the university. If these two resistors are in parallel, and we want to get the effective resistance, if the effective resistance is R, you still remember that the effective resistance 1 over R is equal to 1 over what? Plus, giving us that we have R1, R2, and then R2, R1. So it simply means that 1 over R is equal to R2 plus what? R1 upon R1, R2. If we now do the reciprocal, that is the inverse, we now get R, which is what we are looking for, which is R1, R2 upon R2. This is what you must always remember. It shouldn't leave you. So when we come here now, come and clean the bottle. So we say let R3 plus R4 be equal to what? Maybe Rx. We are trying to compute the effective resistance of this circuit. We can always sum this one since they are in series. Okay? Now, we now have that R effective is equal to R1 plus R2 times what? R what? X upon R2 plus what? Rx. If the values of all these resistors are given, then you'll be able to compute what? The effective resistance.